as quickly as possible just the content necessary to load up our application UI. So things like the toolbar, the drawer, maybe some cards. And then later on, we dynamically populate that view with our content. Now, this type of model works particularly well for single-page applications, but it's nuanced. You might be working on a content-heavy site, and it might be more important for you to get actual text down to your users first. So just keep that in mind when you're evaluating your options when it comes to these types of architectures. But if the application shell architecture does make sense for your app, the way that you achieve some of these improvements in addition to Service Worker is doing things like relying on critical path CSS. So inlining the critical styles for your application shell in the document head, and then asynchronously loading in the CSS and JavaScript needing for the current view. We can then use things like the async attribute on script and libraries like load CSS from the filament group for being able to synchronously load in the content that we need. And the performance wins of such a model are actually quite stark. What you'll see if this is working there is on repeat view, it's almost instant. This is like the simplest version of the application shell architecture we could come up with. And you've got instant performance for the repeat visit compared to the first visit where it took much, much longer. So let's talk about React. React is a UI library for creating interactive, stateful, and reusable UI components built by Facebook. Uses a virtual DOM, try doing the least amount of DOM manipulation, try keeping your components up to date, and it works really well on both the client and the server. Now, I'm a big fan of Hacker News. I use it every day. And I thought, maybe it would be useful to be able to try using Hacker News offline. Unfortunately, Hacker News doesn't work offline on the site. You'll get the dinosaur if you try using it. By the way, this is the dinosaur that we have over in the mobile web area. You might notice that it seems to have like 4 legs for some reason and 2 arms. I just wanted to clarify on behalf of the Chrome team, the back 2 legs have been deprecated, but they haven't been removed just yet. Plan on. So back in 2014, Hacker News actually announced that they now have an API, an open API that anyone could go and build a Hacker News client with. And that API was based on Firebase. This is a real-time API. Anytime someone goes and makes a comment, you can actually stream that latest content through to your Hacker News clients. And so I decided to go on GitHub and try to find out if anyone had been hacking on a really interesting Hacker News client. And I found this one by Johnny Buchanan. This is a really nice client. It lets you take a look at all the different views available in Hacker News. You've got new comments, show, ask, jobs, and it'll highlight anytime a new comment is updated or someone has gone and edited their comment. Unfortunately, this didn't work offline either. And so I thought, it would be kind of interesting if we went in and explored what it would be like to take this complex React app and turn it into a progressive web app that worked offline. So the first thing we needed to do was make it responsive. And I know that sounds silly, but it's still quite a common thing for people to forget this one step. So we went in and we optimized things like the amount of viewport real estate being used on mobile. We wanted to make sure that it actually used up as much space as possible on iOS and on Android. We wanted to avoid things like overlapping menu items, so we fixed those as well. All of this is just done using media queries, and it's nothing particularly special. The next thing we added was the web app manifest. So I went into this project, and I noticed that they had a really tiny favicon, and that wasn't going to cut it. So I redid all of the artwork in Sketch, and exported all the icons out and set up a web app manifest so that we could launch this thing from the home screen and get a splash screen. This is what the manifest looks like. It's nothing particularly crazy. But we basically have a background color set for the splash screen, and we have another color set for the theme color, and we've got our icons defined in there as well. Now, this application is actually a lot more complex than it might initially seem. We have this large set of complex real-time data being streamed to the client, and then we have this application UI, this skeleton that we're using across all of our different views. So we're going to split this problem into 2 parts. The first is caching our application skeleton, and the next part is going to look at content caching. Now, for caching our application skeleton, we're going to use 2 libraries, SW Precache, which is a build tool that will go and help you precache all of the assets that you need for your first application shell render. And then SW Toolbox, which is a library for handling all of your dynamic views and content that might get rendered later on. Now, in this application, like many React apps, we're just using Webpack behind the scenes for our module bundling. But pre-cache can actually be added on after the fact. So here I've just got some NPM scripts set up for this project. I've got SW pre-cache set up as just another step that I run after my build is completed. And I'm configuring it using a pre-cache config file in my package.json. So this is what the config file looks like. It's basically importing in toolboxes. It's importing in some rules for runtime caching. And I'm able to configure things like what other files I might like to have cached inside there. Now, in runtime caching, I can specify what other origins I would like to be cached. So in this case, I've set it up to cache anything coming back from Firebase, from the Hacker News Firebase API. And I can also set it up to cache things like Google Fonts or anything coming back from the Google CDN. My last step is going and actually registering my service worker. So I add the boilerplate code to my index file and just make sure that it's registering the service worker that's being generated by SW precache. And once I go and I load up my page and I look at a repeat view, I can see that all of my static assets are now being served from the service worker cache in DevTools. So I go into airplane mode and I check out this app, and I'm happy. I've already opened this up before. I'm starting to look at content I've seen previously, but there's something wrong here. Although my application shell consistently renders really, really fast offline, as soon as I close that app, I'm still in airplane mode, I launch it from the home screen, I get this, no content. The reason for that is that Firebase's offline support is limited to the session that the user currently has. As soon as you close that off and you try going and relaunching from the home screen, you're not going to be able to get that same session data back. You need to actually cache it a little bit separately. So that leads us on to content caching, and something I've spent the last 4 weeks trying to solve. So Firebase generally, because it's real time, it works using WebSockets. This is us just expecting some WebSocket frames in DevTools. You've got little bits and pieces of comment data and metadata that you might use to construct a comments page. Now, I first thought, maybe it'd be an interesting idea to store anything that comes back here in IndexedDB. Unfortunately, I'd forgotten that IndexedDB is the worst API known to man, and should probably be burned. Luckily, there exist a number of really good abstractions for working with IndexedDB, things like local forage, Dexy, IDB by Jake Archibald. And so here we are inside of our React app once again. I'm just consuming the Firebase API the same way you would today. And I thought, maybe I could be a little bit clever. What if I built some middleware that would basically proxy anything coming back from the Firebase API to IndexedDB, and we just stored that? It seems like a not terrible idea, right? It seems like it would be fine. Unfortunately, what happened there is if you went and saw any story on the top stories page, and you opened it up, about 10 to 15 seconds later, you'd end up with 3,000 or 4,000 records in IndexedDB. You wait another minute, it'll grow to 4,000 or 5,000, because you're dealing with real-time data constantly updating IndexedDB as you go. On mobile, if you open up an app where you've had a large number of records stored because you've been looking at lots of pages, you want all of them to work offline, what will happen is that in this app, we had to iterate over the entire collection. It ended up grinding Chrome to a halt, and that just wasn't good enough. So I then said, OK, well, maybe I should rethink this problem a little bit. What if we just used web workers? So I was using local forage. I thought, OK, I'm going to batch all of my writes for this application and only try storing them maybe every 30 seconds instead. Unfortunately, IndexedDB is still really bad when it comes to these types of problems. And I found that just still wasn't good enough for this app. And I had this revelation. I was sitting in an airport lounge, and I thought, well, I don't really need this data to be entirely fresh. I don't need it to be updating every second, so I have every single comment. And I realized that Firebase actually has a REST API. And the REST API allows you to basically go and fetch a static version of content from a JSON endpoint. And that's something that's much, much easier for you to cache. So imagine we have our comment page, and we have all of these different comments. I just have JSON endpoints for every single one of them that I can go and cache. And that's what we do. So I introduced an offline mode into the React Hacker News client. Here I am. I'm still online. I've launched my app. And I'm just going to go and take a look at one of the Google articles here. You'll see that this is a page that has a lot of comments. There's a lot of content here. We're scrolling. Maybe I'm on the tube or on a bus or something. But I still want to be able to view that content offline. So I'm going into airplane mode. I'm just going to relaunch that app. And with content caching in place now, using the REST API, I can actually cache all of that data in the service worker cache API instead of just using IndexedDB. And as you'll see, it just works. I can load up any of the pages I've previously visited, and they'll just work fine offline. I ended up delaying a 300-person flight 10 minutes just so I could get the pull request in for this feature, because that was how happy I was I got this working. Now, one of the lessons there was that I had to rethink what I wanted my offline experience to be. The technical side of getting service worker set up and caching set up, that wasn't hard. It was just crafting the right user experience. Next, we're going to talk a little bit about universal rendering. So Paul Lewis put up these really interesting graphs a few weeks ago. He said that in a JavaScript-based render, you're usually reliant on all of the script to be downloaded, parsed, and evaluated before you can render the page. This ends up wasting a lot of time when the HTML arrives to when you give the user something meaningful on the screen. Something slightly better is the situation where we see a lot of frameworks moving in at the moment. You have a server render with hydration, where you send a view to the user. The downside of this is that you're still reliant on the JavaScript to actually be loaded up before someone can interact with your application. And this can result in a little bit of an uncanny valley where the user sees that, the application, but they tap and nothing actually happens. Somewhere that would be amazing to see a lot of frameworks move to is this idea of progressive rendering in Bootstrap, where you send a functionally viable but minimal view in HTML with your JavaScript and CSS, and the app progressively unlocks more features as the user starts traversing and navigating around it. So I'd love to see more of us move in that direction. For the server-side rendering portion of the React HN app, React Router was just amazing. Worked really, really well on the server. We found that we were able to reuse most of our routes with very little effort. We just put together a very quick Express server to get this set up. Some of the little lessons that I learned along the way were just making sure that we properly guarded ourselves around globals. This app was still making use of things like local storage and session storage, so we had to guard ourselves so that wouldn't fall over. We had to minimize reliance on things like the DOM. The previous author was doing things like using the DOM to parse out the host name, so we had to just switch away from doing that. Now here's where we ended up. We started off in a place where on cable we had a speed index of 2063. And by the time we'd added service worker and server-side rendering, and we used all of these content caching techniques together, we got to a place where we had a speed index of almost 1,000, so close to perfect. Now on 3G, where it's even worse, we're still in a pretty good place. We're in a place where we started off with a speed index of almost 4,000, and we end up in a place where, with service worker caching and content caching, we've got a speed index of 1,400. Now, these type of experiences, this is something that I've done just over the last couple of weeks on an existing large React code base. So if you're in a position where you have something similar and you want to turn it into a progressive web app, it's very, very possible. The tools are just there. So I encourage you to try that out. Next up, we have AngularJS. So Angular is a framework that's been around a very long time. It tries to tackle building complex applications, originally focused very much around being data first and using declarative HTML and data binding. I'm going to talk about Angular 2, but before we do that, I know that there are still people that build on Angular 1 or have existing legacy Angular 1 apps. And you might be wondering, well, a lot of this progressive web app stuff, great. Does it work with Angular 1? Yes, but with caveats. So I tried building an Angular 1.5 app just to demonstrate this, and I was trying to think of what app I would build. I initially thought of building like an app that would show me the nearest places I could go and skydive. Then I realized that I don't skydive. The closest thing to me skydiving is probably zooming in on a Google map really, really fast. And that's basically the same thing, so I'm fine with that. So this is the app that I built. It's called Cherry. Built this in about an hour or two. This is using Angular 1. As you can see, we've got add to home screen features, splash screen, offline support with service worker. Unfortunately, the downside to this app is that it just doesn't meet our performance budgets. You take a look at, on 3G, you take a look at, where your goals are for fast first paint.